Hello and welcome to the Weekly Space Hangout for Wednesday, January 16th, 2019. I'm Fraser Kane, publisher of Universe Today. This week, we're going to be talking about the magnetic pole is moving really fast. Titan in infrared, a planetary disk that rolled over, an update on 2018 cow, where 18 cows in 2018 turned into a supernova. And there's life on the moon that China put there. All right, joining me this week, we've got... another doctor. Special guest, Dr. Pamela Gay.
Hi.
Dr. Morgan Renberg.
A cow going supernova is just like the stuff of nightmares.
2018 cows going supernova? I forget the number.
Geez.
Yeah. And Kimberly and Paul are off this week. But that's why we brought in Pamela to sort of, bring in some extra
Give us
help.
knowledge.
Exactly. So it wouldn't just be me and Morgan just talking and droning on about everything. So before we get into this week's episode, as always, I want to give a big thank you and shout out to our good friends at the Weekly Space Hangout crew. You can join this amazing community. Go to wshcrew.space. And they will give you all the information to be able to join the community. You can join the chat that's going on down below at the bottom of the screen and more. So go to wshcrew.space. Now, before we got started, we were supposed to remember something, Pamela or Morgan, to promote the eclipse.
Oh, the Astro Tours?
Well, the eclipse for sure, and then maybe the Astro Tour shoot. But if Paul was here, we'll do that at the end. We'll promote all the stuff at the end. So why don't we get into the interview portion? Joining us this week on the Weekly Space Hangout, we've got Paul MacNeal. Paul, welcome to the Weekly Space Hangout.
Hi there. Hi there.
There he is. Okay, Paul, who are you? What do you do?
Let's see. I'm a mechanical systems engineer at the Jet Propulsion Laboratory in Pasadena, California. And I created and host the JPL Invention Challenge, which is an annual contest open to all middle and high schools in all of Southern California, and also friends and family of JPL. And I can get into some of our international flavor later on.
Well, right. So for people who have never heard of this challenge, what is it?
It's basically an engineering-based challenge where I send out a set of rules in mid-August to everybody on the official email list, and it's really easy to get on the official email list. You just contact me, and I put you on.
Okay. Paul MacNeal, JPL, you'll be able to find it.
Actually, if you just Google the JPL Invention Challenge, there are all sorts of links to our website. Also, you can even Google my name spelled correctly, and you'll actually get to the same website. So every year, like I said, mid-August, I send out the rules. Last year, as an example, I had the vertical or the upright pipe contest. Everybody had to start with a 2-inch PVC pipe, schedule 40, about 24 inches long. I would hand it to them basically in a horizontal position, and they had to set it upright onto a platform in the quickest amount of time. And that was the challenge for this year. In the past, one of my favorites is the jelly bean launch contest. I handed teams 50 jelly beans, and they had to launch them into basically a skee ball target. But because I had so many teams running, I handed 3 teams 3 different colored jelly beans, and they all went at the same time. And they had 1 minute to launch jelly beans into like the center circle, then the bigger circle, and so on. You get more points for the smaller target. That was very fun. But we've had every year, it's a completely different set of rules. I don't know how I keep coming up with different things. If you go to the JPL website, you'll find the rules for all 21 contests. This is we just finished our 21st year, the 20th anniversary. Started in 1998.
That's awesome. Right. So who are the teams? Who are the people who come to compete in your wacky challenges?
Yeah. Back in the early 2000s, we got some help from an organization called MESA, Math, Engineering, Science Achievement, and they sent out requests to their local organizers to recruit high school teams and middle school teams to join the challenge. And so before that, we didn't have very much student participation. After that, we had very good student participation. As a matter of fact, last year we had 83 teams join. I allow 3 teams per school, and I've had schools as far away from Santa Barbara, San Diego, let's see, also all the way out to Apple Valley. I mean, they come from all over, realizing that the most they can win is a trophy that's about 12 inches tall. So it's really for bragging rights, and it's for the thrill of competition, and it's also for the thrill of learning something other than reading something out of a book. The contest is basically, I give them nothing. The entry fee is $0, and they start with a blank sheet of paper, and they have to read the rules, try to figure out what the limitations are, also try to find out what the intentional loopholes are. I always throw in some things where most of the people won't think outside the box, but if you do, it's legal in some cases.
So how long do they have? Like, you know, you hand out the rules. How long do the teams have to actually come up with their solution? And where are they? Like, do you provide the raw materials? Or are they able to go and do anything they want? Like,
it's
off-site?
Basically open-ended. I am very cheap. I provide nothing.
Right.
And so I've had teams, I've had professional teams come in and spend thousands of dollars and just fail miserably. I've had teams make stuff out of cardboard and duct tape and do very well. So it all depends on the contest rules. Sometimes you might have to build something out of wood because there is a little bit of force involved, but nothing where you have to machine something, or nothing where you have to go out and buy some computers and get a lot of parts. The intention is a relatively simple contest. Matter of fact, I in my head imagine a viable device that will cost under $50, because I'm not trying to make this a difficult entry for any middle school or high school. We have a lot of schools that enter where they are extremely poor, and they still manage to find the $10 or $20 needed between maybe the 6 teammates to come up with a device. And so I really like this aspect of the Invention Challenge because it's affordable.
And so how long do they have? Like, from when you release the rules, how long have they got?
The regional contest, because we have so many teams and I can't take too many teams at the finals, which are held at JPL, we have a regional contest the Saturday before Thanksgiving. So that's about 3 months, 3.5
Oh, wow.
months.
Okay, so they got quite a while to come up with a solution to the problem.
Oh, absolutely. And they get a chance to go through the process of design and failure and redesign.
Yeah.
And retest and retest. You can actually tell which teams procrastinated 3 months and did it the night before. You can tell.
Yeah.
Because it doesn't work the first time. Yeah.
And so then all of the teams have to, on the same day, they all have to run through the gamut and demonstrate their solution to the problem. Like, that all gets done simultaneously.
That is correct. And we have strict time limits on setup, because it'd be unfair if someone took a half hour and another team took only 2 minutes. So we always give the teams about 3 minutes to set up. While they're setting up, one of the students on the team talks to the audience and says, "We're from San Marino High School," or "Here are my teammates," or "This is how we did it." Some people don't know how to speak and just say hi, and that's about it. But it runs the gamut, and some of the students really love to talk and explain everything in glorious detail. So,
I got a question from John Victor that I thought was great. What are some examples of the loopholes that you might put in? So if you say you put a loophole into the rules, what does that look like?
it's not that divisive. I'm not trying to make something difficult, but it's sometimes what I don't say. For example, there was a contest where I was not really too worried about the height of the device, so I only gave the dimensions of the length and the width. It was amazing how many people asked, "Well, what's the height?" Because everybody's so used to getting very restrictive rules, and I try to open it up as much as possible. My favorite entry of all time was actually called the loophole, and it was I think it was early 2000. We had the water balloon launch contest. You had to create a device that was no taller than 2 meters that would launch a water balloon that I supplied, and it would have to go as high as possible and then land in a 10-meter circle, which is a pretty big circle. But you would be amazed how much energy was put into these, such that the one that went the highest was about 240 feet straight up. And it landed about 50 feet outside the circle. so that one did not count. There are others that were more moderate, but 180 feet is quite impressive. Since we were next to a building that was only about 9 stories tall, it cleared the building and came down and landed. That was amazing. The loophole was that I didn't have any way of triangulating to get the exact height, so I used a stopwatch, because I figured every water balloon has about the same amount of coefficient of drag. It's all about the same weight. Weight doesn't have much to do with it anyway, but it all has about the same weight. So I said, as soon as it clears the 2-meter mark, I'm going to start the stopwatch. And when it splats on the ground, I'm going to say, okay, that's the time. And then I had a lookup table to convert based on parabolic motion and gravity and so on, how high it went. And one of the guys, he was more of a professional team, said, that's interesting. Time is how you determine the height. So he created 3 parallel leaf blowers, and he blew the water balloon up 6 inches off of the device to clear the 2-meter mark. And he just held it there, and he was actually able to move it around and demonstrate that it was fully captured in his stream. After 45 seconds, I said, stop, you
win.
Clearly have, taken care of the height. It calculated out to 1.6 kilometers, just wondering. And I couldn't give him the highest because clearly it moved only 2 inches. I did give him the loophole award, though.
That's awesome.
He told me about it before he came, and I told him legitimately that I can't give you the highest, but I will certainly give you a trophy just for this tremendous effort. I never imagined that someone could actually levitate a water balloon mechanically. They used a leaf blower.
That's amazing.
So that's a loophole. Some of them are much more subtle.
Yeah. Now I know your goal. I mean, right now you've been doing this at JPL, which is in Southern California, in Los Angeles. But your goal is to make this more of an international event, right?
Actually, we have had some international teams already participate. Oddly enough, about 12 years ago, I got an email from someone. He said, "I'd like to enter next year. Is that okay?" I said, "Well, where are you from?" He said, "Istanbul." I said, "Well, that's pretty far." And we had further dialogue, and it turns out he worked at a university, and so he was able to convince professors and the administrators at the university to hold the Istanbul Invention Challenge. And they use my rules, and the day after I hold the finals is the day that they actually hold their contest, using the same rules, maybe slightly modified due to local, traditions or Like if I say use this kind of a solo cup, well, they can use whatever cup they wanted to use.
But you're hoping to get the challenge done in other locations as well. I mean, you've had entrants
It was done in Istanbul for a number of years.
Yeah.
I'm working now with a team. We had 3 teams this December, come out and participate from Ethiopia. And they had participated the year before as well. And I said, well, why don't you consider the African Invention Challenge? And I think they're actually leaning towards maybe the Ethiopian Invention Challenge at Addis Ababa, which is the capital of Ethiopia. So we'll see where that goes. It does take energy. It takes a high energy, motivated organizer. We could do it anywhere in the country, any company, or even another NASA site, as an example, could host a challenge of this relatively simple magnitude. I actually spend about 25 to 50 hours a year organizing this. And most of that time is spent in the last few weeks before the contest. And I get 30 volunteers to help make sure everything moves smoothly, because we have to process badges. We have to make sure that all the students get cleared through the security that we have at JPL. But we always have a good time. It always seems to work well. And there's only 2 years out of 21 that we had to go indoors because it was rain. So it's pretty amazing.
So, Paul, if people do want to run the challenge for themselves, maybe, if there's anyone at NASA listening right now, then they want to run at one of their NASA centers, or if someone, maybe a company or teachers in another country or city, how can they go about contacting you and organizing the event in their own area?
I think the easiest thing to do is just send me an email, because we all know that emails are instantaneous just about. And do you mind if I give out my email
Sure.
address?
Is it the paul.d.mcneil@jpl?
.nasa.gov.
Yeah.
Just make sure you spell MacNeil correctly, and
MacNeil.
MacNeal.
Yeah. But Google the Invention Challenge, the NASA Invention Challenge, and you will see all of Paul's information, including his building at JPL and his phone number. So it's all there for you.
Number 2.
Yep.
And that's the easiest way to get some feedback. My recommendation is, if you're planning on holding it, you need to get the rules out mid-August. You should probably start getting your venue and getting your organizing your volunteers about 2 to 3 months in advance. If you're doing it at a school, always make sure the principal knows what's going on. The last thing they want are surprises, especially when mechanical devices with high energy are involved.
That always sounds like good advice.
You are allowed to check your email since you're at JPL.
What's that?
And you're allowed to check your email since you're at JPL.
Oh yeah.
Right now, while the furlough is happening, yeah. Paul, yeah, no one's allowed to talk about this. Paul, thank you so much for coming on the Weekly Space Hangout. This challenge sounds awesome. I would have loved to have done it as a kid, and maybe we should do it here somehow. But anyway, we'll be in touch.
Form a Weekly Space Hangout
Weekly Space Hangout team, exactly. Yeah, we'll join.
Get beaten by a bunch of middle schoolers.
We'll get destroyed.
I can let you in through the side door, because I organize it.
Perfect. All right. Well, Paul, thank you so much for coming on the Weekly Space Hangout. I can't wait to see the 2019 challenge and what fiendish invention you have planned for this year. Let us know when you're live. We'll let everyone know about it. Thanks a lot for coming on the show.
All right. Thank you very much.
Thanks.
Bye-bye.
All right. Let's move on to this week's news. Let's see. We'll go with Pamela.
Yes.
I want to hear the which story do you want to talk about first?
Let's talk about the double star that's actually 4 stars and perpendicular to its disk.
Right on.
So a group of researchers working out of Warwick University used ALMA large millimeter array, as you do, to observe a binary system that they knew was quite young. They knew it was binary because there's two stars. They can see the two stars. They'd observed the orbital orientation of these two stars. They looked at the system with ALMA, and lo and behold, there is the young protostellar disk around it. It's roughly the size of our own solar system's asteroid belt. The weird thing is, it is perpendicular to the binary stars. The analogy that's used in the press release is, imagine that you have a merry-go-round going round and round and round, parallel to the surface of the Earth, but sitting in the center of a Ferris wheel. In this case, that planetary disk is your Ferris wheel with a merry-go-round of two stars in the center. Now, we'd known that you could have planets around tight-knit binaries just like this one, but this orientation is nothing like we'd previously thought about, which just tells us the universe once again found a way to be more creative than we are. And what I find really cool is, as they observe this system more, it has two more stars outside this planetary disk. So if planets form in this disk, they're going to have two suns casting two shadows in the center, and two distant stars also rising and setting beyond. And who knows where the shadows are going to be. The seasons are going to be completely bizarre. And someone has got to write science fiction about the planets in this system.
So you just described it in a way that completely blew my mind, because like always the answer is, the stars formed in a planetary disk and everything is all lined up and you get day and night, but in this situation the thing rolled over so that now it is oriented in this polar direction, which is the opposite of what we have here in the solar. And people always ask, could there be planets that are orbiting outside of the plane of the ecliptic? And the answer is, unless something really weird happened, no.
Turns out stuff that's really weird happens.
Right.
The universe is vast. In its vastness, it finds ways to do really confusing, how does that angular momentum even work kind of stuff.
And that's what I'm really sort of confused about in this situation, is we usually think of protoplanetary disks as being really strongly coupled to the magnetic fields on these young stars. Young stars have really powerful radiation that ionizes the disk and really strong magnetic fields, and those fields basically drag the disk around. And you imagine that would kind of lock the disk in place around the plane of the star. And so how did they get disconnected?
Even more simplistically than that, it's that whole tossing your pizza dough analogy of, you have a cloud of material that flows in, spirals up in the process, and everything is more or less going in the same direction. But these stars were like, nah, we're just going to be at a right angle to everything. And I have to admit, while our guest was speaking, I was subscribing to Nature magazine so that I can get my hands on the full paper. And it's just a cool story.
Yeah.
Apparently so cool, I'm willing to spend $66.
You're a maniac. Is the thing still tumbling? Is it that the disk is tumbling around and we happen to see it at a moment, or it's now stable and locked into this new position? Are the stars the ones that turned over? I mean, I guess it's all relative. Or did the disk turn over? And what's the mechanism?
There's two other stars, and that's why I'm buying a subscription to Nature.
Wow.
You're
welcome, Nature.
That's dedication.
Yeah.
Well, I realize it's probably not going to be only this story.
There's
this
other.
year, so.
Yeah.
I need to know the answers. I do not understand, and it is awesome.
Yeah, and unfortunately, it's not on Astro PH, I'll bet.
No, because
Not if it's on nature.
Not in nature. Oh, wait. No, it's not. Well, that is really amazing. Morgan, what do you got?
I want to talk about our North Pole and the fact that we sort of have two North Poles. We have the actual geographic North Pole, where the Earth's spin axis kind of pokes out of the planet, and we have our magnetic North Pole. And they're offset by about 11 degrees. And this is not something that we think about all that much, because over small scales, that difference isn't really that important. But over big scales, like if you're navigating ships or flying airplanes, that's a big deal. And to make things even more confusing, while the spin axis remains stable over sort of medium-term lengths of time, the magnetic pole wanders around because of sort of turbulence inside the planet that causes the magnetic field, bubbling and moving in different directions. And so that point at which it punctures the Earth's surface is a little different every moment. And for basically as long as we could measure, from the 1800s through the 1900s, it would drift by about 15 kilometers a year. But something happened in the late 90s, and suddenly it's drifting at more like 55 kilometers a year. And right now it's moving so quickly that the government that measures and tracks this has to issue basically an emergency update to the algorithm that predicts where it will be. And normally that algorithm is issued every 5 years. And it's due to be issued again in 2020 with new updates. But they're pushing out as soon as the government unshuts down. They're going to push out an update here in 2019 because it's moving out of Canada, the magnetic North Pole, and into Siberia. And this algorithm basically takes your compass reading and converts it to a northern pole in geographic terms. And we all use this every day without knowing it. If you've ever gotten walking directions on your phone and you get that little blue arrow that tells you which direction you're facing, and so you know whether to go left or right when you get to the next intersection, that doesn't come from GPS. That little blue arrow comes from the compass inside of all of our smartphones. And in real time, our phones are applying this algorithm to turn what the compass says is north and make it what the map says is north. And these shifts are tiny and aren't going to cause you to cross the street in the wrong way. But if you're flying a plane around the world, suddenly those will start to add up. And that's just crazy. We think of north being north. And first off, there's not one north but two, and they're both moving at measurable rates fast enough to impact our lives.
The thing that I find is funny, so the pole has moved into Siberia and it's crossed the international date line. So now the magnetic North Pole is like tomorrow and it's on its way to Siberia. So in Canada, we have lost control of magnetic north.
We don't have a good idea why this is happening, but one hypothesis is that there's a sort of a jet of molten iron in the outer core underneath Canada. And that jet is kind of inhibiting the formation of magnetic field around Canada. And there's kind of two hot spots for forming magnetic field lines in the Northern Hemisphere. There's one under Canada and one under Siberia. And so if this jet is weakening the part produced under Canada, and the pole is basically the average of those two, then it's sliding the pole towards Siberia. Nothing's really changing in Siberia, it's changing in Canada. And that just means that the average of those two is drifting away and toward, it's actually getting closer to the geographic North Pole than it has been in quite some time.
And the other, we talked about the government shutdown. Of course, the grand irony is that they have a big update to do and they weren't able to push the update because of the shutdown. So
I was just trying to read about this model and the government pages are literally turned off.
Yeah.
And I had to go to it's jointly issued by the US and Britain. And I had to go to the British Meteorologic Service to find out what the heck was even going on.
Well, that works.
So, yeah, well, there you go, right? That's why we have these partnerships, so that when you shut your government down, we are able to pitch in and help you out. You're welcome.
We'll take it.
um, all right, so let's move on to the Chinese lander, and I just want to show you guys just an incredible video of what the Chinese. There's a whole bunch of videos actually, so we're just gonna watch. It's like, when the teacher just puts on television in your class, and you just you do that for the day. So so check this out. This is, and I'll show my co-host so they can see what we're looking at. So this is the landing video from the Chang'e 4 lander as it was coming down to the surface of the moon, and this was released by the Chinese last week, and it's just a stunning video. The whole thing is 2 minutes 47 seconds, so I'm just going to scrub through. We'll get through like the boring parts.
It reminds you of the videos from the Apollo missions.
Yeah.
Landing.
Yeah.
And it's so much better than the videos we get when we land on Mars.
So,
Well, it's going a lot slower.
Yeah, well, and there's no heat shield to block the camera.
yeah.
Well,
I
there's
think
that.
that's part of it.
And this is why
but
it's so great to have like a propulsive landing, a nice, slow, gentle propulsive
That's just
landing.
wild.
Yeah.
Down it goes.
Yeah. And then, we're just about at the ground. Like, where's the ground? When does that start? And then you'll see the
That's the crazy thing
exhaust.
about the moon is that there's craters at all scales, and so we could still be 50 kilometers over the surface for all you know.
Yeah.
But really, it's,
Yeah.
2 meters off the surface.
And then you'll get the exhaust closer, closer. Like, are these 2-meter holes? Are these centimeter
No,
holes?
they're 2
Boom.
centimeter holes.
Yeah, they were.
Yeah.
You just have no idea.
Yeah. So that was one, which was, so that was sort of like, that was the landing and the descent. And then we've got another one. Let's do the one of the rover deployment. So this
I
is,
haven't seen this one.
yeah, so this is the rover deploying
That's
out
cool.
onto the surface of the moon. And
Look at their tires. They're totally different from
Yeah.
what we did.
now, have you, like, they colored everything sepia tone. And did you, and I guess they just haven't done enough color correction on the video. I've seen some others that they've done where you do see it. But that's so awesome. All right, I got one more that I want to show you. Oh, is there two more? No, one more. Okay. And so this is, oh, there's some music here. Hold on. And this is U2 on the surface of the moon. And this has a more appropriate color.
This is just really cool because we never see this stuff on Mars, right? You never get to see the rover driving around because there's nothing to take a picture.
Yeah.
This is
I know. This is just
awesome.
This is like
look,
Pathfinder.
we have never
Yeah.
seen live video, almost live video, of a spacecraft noodling around on another planet, right, or another world. Like, this is a thing that we've never seen with the Mars. They could have done this, and they could have
No,
done
they
it with
couldn't.
time.
It's many light minutes away.
No, but they could record the video and then send it later, right? But this isn't
and I
happening
think they
right
did
now,
that with
Pamela.
Pathfinder. No,
Yeah,
I know,
they-
but I
yeah,
think they
they
did that
built
with
a-
Pathfinder.
Yeah, they built a like, they did it after the fact, right? So they could have done that. But this is a situation where you've got the two spacecraft working together. You've got the lander that's able to view the rover. And so the other big piece of news that I just wanted to mention as well is the Chinese had on board the lander an instrument that would germinate seeds, that would grow seeds on the surface. They had cotton and potato. I forget, there was one other.
In a contained vessel.
Yeah.
They're not planting
Yeah.
them in lunar soil.
Yeah,
Which is
no.
what
It's
everyone
it's
thinks
just
when they saw
inside
the title.
That's right. It's just inside the spacecraft itself, and so they actually germinated and grew and reached out for the sunlight on the surface of the moon, and will be dead soon because shortly the lander is going to go into the lunar night. It's going to be minus 120 degrees.
There's an update to your own story that says it's already dead.
It's already dead. Yeah.
Yeah.
Okay.
They died.
Yeah. So there was briefly life on the moon from us, from the Chinese, and now it's dead. And I think that's super cool. Yeah. Yep. So let's see if I can get the picture here.
Is it just me, or does China feel like they're being a lot more immediately open with pictures and videos of this lander than some of the last ones?
so much better. They have
And-
absolutely learned the lesson from previous things, just like, and what NASA has learned a long time ago, and the Japanese have learned, which is get that stuff out on the internet. The internet is hungry to see and amplify what's going on.
We're talking about it so much more than we would if there weren't any pictures.
Yeah, we wouldn't
And-
even talk about it at all.
There's a certain amount of neener going on.
Yes.
Because here they are. So we had New Year's Day. There was New Horizons flyby with the we can't really talk about it right because NASA's shut down. We had the Dawn orbital insertion. Can't really talk about it right because NASA's shut down. Then we have China landing on the far side of the moon where no one else has landed before, sending us back information, capturing the news cycle and pwning it. They didn't just own it, they pwned it.
Yes.
And they kept it and they're keeping it as long as they can. All of today's top press releases were thanks to China, basically.
Yeah. Morgan, as a planetary scientist, what would you like to learn about plants growing on the moon?
You know, this is going to be kind of a blah answer. I don't know how excited I am about learning stuff here. It's interesting. I think we talked about this last week. We've grown plants on Earth, obviously. We've grown plants on the International Space Station in microgravity. The interesting question is sort of, is this more like growing plants on Earth or more like growing plants in microgravity? And this is a question we'll have to know the answer to before we can grow food for a future Mars habitat or a future moon habitat. But I don't know if there's like a lot of deeply interesting questions between, like, I think if you understand why food doesn't grow well in microgravity, then you kind of can extrapolate in between. Maybe I'm talking way out of my
so this is another point. We currently have a plants hate zero gravity but will put up with it. We have they love Earth. They kind of evolved for this. The moon tells us, do they need Earth gravity, but they're kind of chill no matter what gravity you give them? Or do they love Earth gravity and tolerate, like they tolerate zero gravity? So if plants are kind of cool with growing in a normal way on the moon and don't struggle the way they do on the ISS, that tells us we're good on Mars, where the gravity is a little bit better. So this kind of uncouples the gravity, no gravity to be gravity, some gravity, no gravity. Is it a slope or a binary?
Exactly. I think that's an interesting question. There's all the radiation questions that sort of go along with it too, but in some ways you can simulate that on Earth.
Yeah.
And you can simulate that on the ISS. So we'll get another data point in a couple of years when they grow flowers on Mars as part of Mars 2020, again inside a enclosed capsule. And then we'll have sort of the full spectrum.
Yeah.
As Pamela was saying, we'll have no gravity, 1/6 gravity, 1/3 gravity, 1G. And hopefully we can make some sort of sense out of that. The problem is we're going to need to do it again and again and again. Because we realized pretty quickly that you can grow plants in zero gravity. What you can't really do is grow plants from those plants. The seeds that are created by plants grown successfully in zero gravity almost never germinate a second generation. And we don't really know why. I think that's the key question for answering the moon-based question, is whether we can grow plants and then keep growing plants.
Right.
And so we'll need a bigger, longer experiment to do that, but this is a great first step.
And then grow animals and then keep growing animals. Like the question, I mean, that the deep, really existential question that Elon Musk should be concerned about is what happens when creatures try to live on another world for a long period of time.
Yeah.
And that is, we still don't know the answer to this question.
I don't think we've grown multiple generations of like a vertebrate.
Yeah.
No. They do not like to gestate. Skin doesn't work right in zero gravity. Finding that out is one of the more disturbing biological facts of outer space I've learned.
But the question is, does like, is 15% gravity enough to gestate
Right.
properly?
Right.
Is the 38% of Mars enough to gestate properly? We just don't know the answer. And
Yeah.
and again, like, if it's not, then sending human beings to Mars is a crime against humanity. If it is okay, then it's just a challenge for the adventurous souls out there.
Eventually,
right?
someone's gonna have to have a
somewhere
baby
in that
space,
spectrum.
but we're not ready
Yeah.
for that.
No. I like the articles that are like, we're just going to send a bunch of women. It's just going to be better that way.
What?
Oh, you haven't seen those articles?
'Cause-
There's psychology studies that are predicting that the most successful Mars crew would be a crew of all women.
Because they're smaller?
Well, smaller resources, but also the social dynamics over long periods of time are predicted to be more stable.
Right.
That doesn't seem shocking.
I think we'll have to see some tests done. Someone's going to lock a bunch of people into the Mars, the Mars habitats, and then sort of see how everybody does. Like, when does the space madness kick in?
I think that experiment has been run several times, specifically Mir, when the Soviet Union ceased to exist. Yeah.
That's when the space madness kicked in. All right, Pamela, what else have you got for us?
So there was a fabulous pair of research results announced at the end of last week with the American Astronomical Society conference, and they involved an object that has become known as the cow. This is because it was first discovered as a transient object. This is one of those things that goes flicker or flare in the night. So it got the fascinating, is the word I'm going to choose to go with, name of AT 2018 COW, which spells cow. The AT stands for the supernova survey that was used to find it, or the transient source survey that was used to find it, the asteroid terrestrial impact last alert system telescope in Hawaii. So that explains the AT. The COW is a little bit harder to explain, and I'm explaining this for a reason, so bear with me. So originally we named things like supernova. So there'd be supernova 1987A, supernova 1987B, and we might get to Z by the end of the year, but probably not. But then we started building all of these surveys. So it would go A, B, C, D, get to Z, start over with A, B, AC, go through until it hit ZZ. And people are like, holy expletive, Batman, how do we keep naming these? Well, we're lazy. So it then became AAB, and it kept going until you eventually got to AT 2018 COW. And it turns out there is no censor on the 3-letter words allowed. So there are some expletive named transient objects out there.
Right
I
on.
have confirmed this.
Nice.
And question becomes, what happens when we end up with so many supernovas we go to 4-letter words at the end? But that's a different article. I'm just laying this out there.
Right. This is a future
I have never thought of this.
that we should be concerned about, or excited to usher in,
or both.
or both.
So anyways, cow. Cow is a mysterious object that went flare in the night. It is superimposed or part of the galaxy CGCG 137-068. It's about 200 million light years away. And the reason I said it's either in or superimposed on is because there's two very different theories on what this is. One of the theories is that this flare that was observed across a whole bunch of different wavelengths of light, very well documented, it didn't look like a normal supernova to one group of researchers. And that group of researchers theorized that it was a white dwarf star, the dead remnant of something like our sun. It's compressed down to about the size of our moon, that was in the process of being shredded by a massive black hole. Here, when I say massive, I'm talking something order of 100,000 to 1 million times the mass of our sun. This is the kind of object we expect to be in the center of a galaxy, not out in the suburbs of a galaxy. So if it is a black hole shredding a white dwarf, as one team thinks, it may actually not be in the galaxy that it's superimposed upon, but actually be in an irregular galaxy, in a globular cluster, in something nearby that we just don't make out against the background brightness. But there's another team with equally good fit to the data who, in looking at it, instead of seeing a white dwarf getting shredded, what they saw was a supernova with an expanding debris cloud that blocked out any light that might be coming from a compact object in the center. So it looked a little different than what we're used to. And so here we have either a misplaced black hole that is the wrong size for where it is, but okay, we can deal with that. Or we have unusual geometry and unusual pattern for a supernova explosion. And we didn't quite ask as a community to have the two research teams duke it out, but they did make them sit together and share a single press conference at the AAS.
Yeah.
And it was all these happy junior researchers grinning while they gave their results. And it was kind of awesome. It's a funny object name that just happened. And it's cool science, and time will hopefully tell us exactly what's going on.
It was funny. You were doing, I sort of dropped in briefly, and you were doing a live stream on Twitch where you were watching the AAS proceedings and then commenting on the discoveries that were being made. So I thought that was great. So we still don't know what it is. It's super weird. Stay tuned. Possibly 18 cows exploding.
Probably not.
Morgan, what do you got?
We can never be sure. Data is still trickling out of the Cassini mission now that we're more than a year after it plunged into Saturn. And what we've got this week is this amazing sort of final radar or final surface map of Titan in the infrared. And this was built out of the Visual and Infrared Mapping Spectrometer, which was an instrument that could look through the clouds on Titan using infrared light and map the surface. And the surface is varied, as you'd expect any complex, interesting body to be. We already knew about these lakes and these sand dunes and these mountains and even possible cryovolcanoes. There's not really anything new in these pictures. I don't know if you can throw up the video.
Yeah, I've got it up there right now.
They have, but it's neat to see it all brought together in one cohesive place. And when you look at it like this, you can really start to see like large scale structure that makes you feel like you're looking at a real world and not just a bunch of snapshot images taken across it. You see these big lakes and you see these inlets and these islands and the same kind of geology that you'd expect to see on a world like Earth, but it's all made of ice and methane and ethane, and is just totally weird from anything that we could think of.
There are some features here that are just so weird. Like right now on the screen, there's like these. Oh, now it just rotated another direction here, but there's these like clearly look like some kind of volcanoes. You said cryovolcanoes. I had never seen this before with this level of detail. Like, where did this come from?
It's a totally new way to look at it like this. And like I said, I don't think there's a lot of really new data here. It's just now that the mission's over, you can bring together the best data from all of the parts and you can process it all on the same baseline. You can spend time nicely meshing it all together. You can run it through Photoshop to kind of clean up your stitching marks. The kind of work that you rarely do during an investigation because things are changing so often. And as we really zoom in here, you can start to see some of the limits of the data. Cassini would be taking these pictures from hundreds of thousands of kilometers away. And if I remember right, VIMS is like 64 pixels across. And so this is made up of a bajillion photographs of these different places. And the only way we're really going to dramatically improve on what we see here is to go there and spend a lot of time, not just a couple hours like Huygens did, but to spend weeks or months flying around and imaging the surface.
Right.
And that's one of the proposed missions that NASA is currently considering, is basically to launch a drone into the atmosphere of Titan that would float around for months, land, make measurements, fly, take pictures, and send all of this data back to us. You know, it would be like never going to the moon and wanting to know exactly what the surface of the moon was like.
Yeah.
You can get great pictures from space, but you can't really understand it until you're plopping around on the surface.
So this will serve as the starting point for the future missions to plot out where they're going to go back and where they're going to explore in more detail. And it was made all the more difficult because of these thick clouds that obscure the view. So Cassini had all the right tools on board to be able to do this.
Better we have now. Like when we dropped Huygens on the surface in 2005, we'd never seen through the clouds. And so they built it to be like a boat, hoping it would land in some liquid, but they just kind of chucked it in and said, we'll see where it lands. Now, when we're planning a new mission to Titan, we can write actual specific geographic questions. Let's investigate that island. Let's look at those sand dunes. Let's figure out what that sea is made of. And that just means that the return you can get is so much better, because we can craft the mission to actually answer things that we know are there, rather than just saying, we don't know what's under there, it's probably cool, let's find out. And so we'll be seeing orders of magnitude better results from the next mission, because we can actually tailor it for what the reality of the world is like.
Just absolutely stunning. One just of the most amazing capstones to this incredible mission. Just beautiful. All right, well, I think we're reaching the end of this week's show. I want to give people a chance to shamelessly self-promote some stuff that they're working on. Morgan, what do you got?
So I'm going to do a rare thing and plug my Twitter account at Morgan Renberg. I almost never write on Twitter, but if you keep an eye over the next couple of weeks, you might see some interesting stuff. I'm curating an exhibit about Apollo right now, and I'm going to be spending some time holding objects from the Apollo missions and checking them out to write captions and things. And hopefully I'll sneak a few pictures of handwritten notes from astronauts as they were descending to the surface of the moon, or windows from Skylab with micrometeoroid impacts on them. So keep an eye out, and we can explore the 1960s together.
Very cool. Pamela, what's something that you're working on?
Oh, man. So check out twitch.tv/CosmoQuestX. We are putting out a daily news show, The Daily Space, at 1 p.m. Eastern, 6 p.m. UT. That is
7 days a week.
Well, Monday through Friday. We do it Monday through Friday.
Yeah, I don't know how they do 5 days a week.
Well, and we are going to be releasing the new updated version of CosmoQuest.org any day now. And due to government funding cuts, I paint 739studios.com. Buy a planet. I'm actually going to go paint Titan after this,
Nice.
I think.
Yeah, it's a good one. Awesome. All right. So as you probably know, this weekend it's going to be the lunar eclipse. It's going to be one of the best lunar eclipses that we have had in the Western Hemisphere in a long time. So North America, South America, parts of the Pacific Ocean, all the way to Africa is going to get this lunar eclipse. But if you don't, I'm going to try to live stream it. Things got a little more complicated than I was expecting, so I'm going to need to get clever. But even if I don't, on my YouTube channel, there's going to be lots of places that will be live streaming it. So if you can...
Some of us may appear if that happens.
Right. So definitely get out there and watch it if you can. It's going to be a good one. It's going to be a full-blood death super mega moon, I think.
There's a wolf involved.
Wolf Death Mega Moon. Cthulhu
Super
moon.
Blood Wolf Moon.
Super Blood Cthulhu Moon? Anyway.
And are you going to channel Paul for us?
No.
Astrotours.co.
Yeah, of course.
Out.
We have to. Well, I mean, Astrotours. So we're going to be at the All-Stars Star Party Joshua Tree in June, and we've got until, I think you've got until the beginning of March to put down a reservation if you want to join us. I'm going to be there. Pamela's going to be there. Paul will be there. Skylius, John Michael Gaudier. We're going to be setting up fancy telescopes and observing every night. We're going to be going on adventures around Joshua Tree, so you should totally join us. Go to astrotours.co and you can find out more information.
And if those dates don't work out for you and you're free in August, I will be taking people on a tour of the American Southwest, what I think is the most beautiful landscape in the US, maybe in the world. And you're all invited to come on 7 days, and Las Vegas, baby, will be involved.
Right on. All right. We shift to this view. Here we all are. Thanks again to everybody watching us today. Thanks to our special guest. Thanks to the Weekly Space Hangout crew. We couldn't do this without you. We'll see you all next week. And thanks, Pamela, for stepping in and helping out. You were awesome, as always.
Thank you.
All right. We'll see you all next week, everybody.
Bye-bye.